end of the last lesson, I snuck in this question. And I said to you, in the next lesson, we are going to learn how to find the area of any triangle. And what we said in the last lesson is that there is a formula. I haven't told you why, but what the formula says is if you take a triangle, and it's any triangle, and you have two sides that are next to each other, so the 5 and 6 are adjacent, and you have the angle in between those two sides, you can find the area of the triangle. And the way it worked was you went a half times 5 times 6 times the sine of the angle in between those two. And what we got for that is we got 14.67 centimeters squared. So that is where we left the last lesson. I kind of just made this claim that from now on, you can use this magic formula to find the area of any triangle. But I want to also go back and say that in grade 9 and 10, and we talked about this too, the formula for the area of a triangle was just a half times base times height, where the height was perpendicular to the base. And so both these formulas work. It's just that the grade 9 and 10 one has to have a right angle. It has to have a height, whereas this formula will work for any triangle. So just give me a thumbs up if you were with us in the last lesson and you remember that. Give us a thumbs down if you're like, this man is talking another language and I need to catch up. Okay, fantastic. So if I'm telling you the truth, and I hope that I am, let's just try it out on a simple question. So pretend that you didn't know about the rule that I just told you, and you had to use grade 9 and grade 10 tools. Could you answer this multiple choice question for me? I'm giving you a triangle. Each block is 1 unit. Can you tell me what the area of this triangle is?
Mr. S, while they do that,
yeah.
Sorry,
Go ahead.
unrelated to this question, Monique asked if you'll be doing trig identities anytime soon.
So Monique, you could have a look. We've done some trig identity videos in the past, so you can look at the recordings. The topics for this section deal more with solving triangles. And so we're going to do the sine rule, the area rule, the cos rule, and mixed questions. So that's a slightly different topic part. And so there are some recordings on that if you look. Okay, let's see. What are the answers for this? So I'll give you a little bit of a hint. If we count the blocks, isn't this length 2 and this length 3? And isn't this angle over here 90? Now, could you find the area of this triangle using just plain grade 9, 10 tools, half base times height? What are we going to get? So the order doesn't really matter, but I think most of you would go a half, and you'd say the base was, say, 2, or maybe you'd say the base is 3. It doesn't really matter. The base is 3, and then you'd say the height is 2, because we've got that right angle. And the answer would be 3 units squared, or 3 centimeters squared, which is option A. Now, just to show you this new magic grade 11 tool will work for this question as well, the area rule would say a half times 3 times 2. And what is the angle in between the two sides? Well, the angle between the 2 and the 3 is 90. I want you to type that into your calculator. What do you get if you go a half times 3 times 2 times the sine of 90? So the good news is you still get 3, which is great news because it's showing you there's no contradiction, guys. You can use the grade 9, 10 tool, or you can use the grade 11, but the grade 11 tool is much more flexible. It's like a Swiss Army knife. You you can use it on all triangles. And so when we find the areas of triangles going forward, we're generally going to use this tool. Now, I haven't told you why it works. For now, we're just taking it on faith, but let's just get used to it. And you will never have to worry about finding areas of triangles again after tonight. You will be in charge. Before I move on, are there any questions or comments? If anybody wants to take a screenshot, take a screenshot. But basically, I'm just showing you how this tool works. Okay, cool. Then over to you guys. I want you to find me the area of this triangle. Note that it is, it's not a 90-degree triangle. At the moment, there is no height. If you were in grade 9 and grade 10, you would say to me, cool, I can find the area of this triangle if you tell me the height, because I will just go 1/2 times 7 times the height. However, there is no height. And so you're going to have to use a grade 11 tool to help you. So find me the area of this triangle. So I think we need to use that side, and that angle. And it will be 1/2 times 7 times 6 times the sine of 60. And depending on if we round off to 1 decimal place or 2, you should get 18.19 centimeters squared. Okay, fantastic. Now, how does this rule actually work? So I want you to imagine, I mean, I think all of you can apply the rule. That's not difficult, given that if you memorize it. But why does this work? So the reason it works is that this bit at the end is doing the hard work of finding the height for us. So this bit over here works out the height of the triangle for us. So let me show you how it does it. You don't need to do this every time. You can just use the rule. But would you agree with me that the sine of 60 is going to be this one over here? So we'll call it the height over 6. So sine is always over h. So it's just h over 6. And then if you imagine moving this 6 to the other side, well, then it will be 6 times the sine of 60 would be equal to h. And so the height of this triangle is just 6 sine 60, which is this bit over here in the rule. So again, all that the rule is doing is it's basically finding the height of the triangle, and that's why it works. Okay, but you don't need to do that every time. You can just use the rule. Just give me a thumbs up if you feel like you sort of understand a little bit more about the magic of the area rule. Hopefully I showed you that basically I just found the height and used it. Okay. So just have a look. Maybe your calculator's on the wrong setting. Okay. Is it always sine? It's always sine, because you're always going to use sine to get the height of the triangle, which is really where it's coming from. Okay. Let's just practice it.
Yes, we have 2 raised hands from David and Valente.
Could you just let me see if I can unmute one. So let's have a look here. Whose hand is raised? So guys, what I'm going to do is I'm not going to get stuck in the height part, because the most important part of today's lesson is just to know how to use the rule. So if you feel unsure about this part, don't worry. Like, the main focus is, can you use the rule? I was just trying to show you where it came from. Okay, so let's move on to the next one. Find me the area of this triangle using this new rule called the area rule, which I've just shown you. So this is not the sine rule. This is called the area rule that we're using. And the reason we call it the area rule, guys, is because we're finding the area. So tonight's lesson is all about using the area rule, and I will write it down formally later in the lesson. But for now, I just want you to practice using the area rule. So Dunel, the area rule says, I'll show you in this example when we do it now. Okay, so the area rule says for any triangle, if you want to find the area, you go a half and you times the ones, as long as you've got one side, another side, and the angle in between, you can find it by going a half, 8 times 10 times the sine of the angle in between those two. And so that rule will work for all triangles in the world. And in fact, they use this in engineering all the time. So to find the area of a triangle, you can use this rule. And you should get 39.27 if you're rounding off to 2 decimal places. And that is the area of that triangle. Okay, so all we're doing at this first part of the lesson, guys, is we're just learning how the area rule works. So I just want to make sure that you're comfortable applying it. Then I'll talk in more detail about how it works. Okay, I want you to try and find the correct answer to this question. And this question is asking you to find what is the correct value for the area of triangle PQR to 1 decimal place. And you are given the triangle here with certain information. There is no mention of heights. So there's no mention of a height. So you're going to have to use grade 11 tools. So can you find the correct answer for the area of this triangle? So where would we start? So a half times 21.2 times 18.1 times the sine of 51. And I can see that all of you guys are getting 149.1 centimeters squared, which is option A. So the good news is whenever you have to find the area of a triangle now, it's really quite straightforward. Okay, now the other thing about this area rule is it works for all combinations of sides. So we happen to use this side and this angle because that's what we needed. But if we didn't, if we had this side and that side and the angle in between, it would still work. So this rule works universally. Okay. But you'll see that later in the lesson. So take a screenshot if you need. And we're going to move on now. Okay, a little bit harder now. So a few distractors. Can you find the area of this triangle? Notice how I'm starting to give you some quite strange looking triangles already. And there's no mentions of bases or heights. To ask yourself, which sides are involved? I think this one would be involved. I think this one would be involved. And the key step is to figure out that it's this angle that you need. You ignore this angle up here. It's not relevant. So you get a half times 12 times 9 times the sine of 75. And what do you get for that? So you're going to get 52.16, but because it's to one decimal place, the correct answer should be A. Okay, so I think that we are feeling reasonably comfortable based on what I've seen. And the first part of the lesson is just to get familiar doing this. Now, I want to get some more student participation going in the second part of the lesson, but let's just make sure that we have this sorted first. So give me a thumbs up if you're feeling good. Why do we choose only those two sides? So Nontokozo, we only need two sides to figure out the area of the triangle. So it's not wrong to have three, but we only need two and the angle in between those two sides. So you'll see that now. Okay, so I think this is, let's make it a little bit trickier now. So we've got this idea, and I want us to think about this question. I'm going to give you more time. And so after let's read it together. Which of the following would correctly work out the area of a triangle? And so I want you to take some time to think. And then once you've had a chance to think about it, if anybody can give us some hints, I would love for someone in the class to maybe share a hint that they think might be helpful for this question. And you just raise your hand, and then you can help us all just kind of get going with this question. Because this is a bit harder. So which of these four formulas will help us figure out the area of a triangle? And if anybody is able to give us some hints or tips to get started, raise your hand. We'd love to hear from you. Okay, so Madeleine has said she can give us a tip. Madeleine, I'm going to unmute you. Could you give me a tip to get started?
So I think the first step is to find the missing angle. And since we were given the other two angles, we can find it by subtracting 180 from the other two angles.
Perfect. What did you get for your angle?
I got 84 degrees.
Perfect. Madeleine, thank you so much. I think you've helped a lot of people just get into the problem. And let's see what answers come through on the chat now. Okay. What answers are coming through on the chat? Which ones do we think would make the most sense? Maybe we should start by writing out what we get for the area and then see which of the formulas match the area. So I think a couple of people are coming through. So I was thinking the area should be a half times 14 times 26 times the sine of 84. And that's where Madeleine's tip came in so handy, because I know I need the angle between the two sides. And so what do we get if we do that? Which of the options do we think will fit with that? It can't be that one. That one doesn't have a sine, so it can't be that one. It might be this one, but it's missing a half, which means the answer must be D. So give us, are there any questions or comments about that? Or do you understand how I got D? Give us a thumbs up if you understand how I got D. Okay, I think everyone pretty much feels comfortable. So, although not everyone, but I think we're going in the right direction. So take a screenshot if you need to, and let's keep increasing our, it's almost like I'm a gym instructor and I'm turning up the heat. So let's turn up the heat. I want to see, can you find the area of this triangle? And this is a little bit more information in this one. So can you find the area? I'm giving you this triangle. I'm only giving you 3 sides and 1 angle. And I want to know, can you give me the area? What would you get for the area of your triangle here? And then level, while the students are working, if any students want to ask an additional question, now is a great time to raise your hand and maybe I can answer your question. Or if anybody would love to give us the answers, raise your hand and you can talk me through, how did you do this one? Oh, I see the answers are starting to come through already.
Yeah.
So it feels like a lot of people are heading towards 44. So let me see what I would do. I would know that I would ignore the 10 because I don't need the third side. And so I'd go 1/2 times 12 times 9. I suppose the key thing is to know it's always sine with the area rule. And so you basically just ignore the 10. I've got the answer down here, so I can actually blow it up. So let me do that. And so you should get 44.23 meters squared. And yeah, I think it's becoming a little bit easier every single time we do this to apply the rule. And you realize actually finding the area of a triangle is just going to mean marks for you from now on. Because once you can apply this, it's marks in the bag. Okay. So what I want to talk about now is how do we apply the area rule in different ways? And so I want to formalize what the area rule actually is. So I'll move down from that. So what is the area rule in fancy mathematical speak? So let's just, because this is what students see in the textbook, and it can be a little bit overwhelming sometimes. So if we think of any triangle ABC, we'll always name the triangle by having the capital letters on the vertices and the small letters on the sides. And you'll see that the big letter is always opposite the small letter. So if I was to write down the area rule, what does it actually say? Well, in English, it says triangle ABC is half the product of 2 sides and the sine of the included angle. And the reason this works is that using trigonometry, we can find the height of any triangle. And so that is what I showed a little bit earlier in the lesson. But how would we write it down in this strange triangle? So if I'm going to focus on this side A and this side B, how would I write down the area rule here? And I would write down 1/2 times the product of 2 sides. So the first product is A, the second product, or the second part of it is B. Now, what is the angle involved going to be? I'm going to write sine of something. Can you guys tell me in the chat, what is the angle that needs to go between those two? I'm just going to wait a moment to make sure that you can. Okay. And it's going to be big C because that's hiding over here. Okay, now I want to set you a challenge, guys. I want you to write the area rule not in terms of A and B, but I want you to write it in terms of A and C. And so I want you to try and write out the area rule for me in the chat. Write out what you think I'm going to get if I'm using these two sides that I've highlighted on the screen right now. Over to you guys. And then after we've done this, we will take a little break. And for bonus points, those who are really feeling like today I'm going to shine, see if you can do the area rule in terms of B and C. That would be the last combination that's possible. So for the, what was I doing? I was doing this one first. So how would we do that one? We always have a half. So there's no problems there. Times A times C times the sine of B. And so that would be the second possibility. Now, what about the last one? What are the only two sides that we haven't used yet? So what about those two? Write me an area rule formula using only the blue and green sides. Let's have a look in the chat. So what I find with students is often they see all these letters and numbers and they don't really know where is this coming from. But if we build up our understanding gradually, then you can see, like here, there's a method. I go B times C, and then it's a sine. And then what's the angle between the B and the C? It's just going to be A. And so whenever we use the area rule, it doesn't matter which two sides we've got and which, well, the angle we've got, it needs to be the angle between the two sides. If the angle is outside, then sometimes we need to work out what the angle is between those two sides. But the moment we have two sides and the included angle, we are good to go. All right, I think that we've done really nicely and we've done the full first half of the lesson and you've been making great progress. And so what I want to do now is I want everyone to stand up and if you can, turn on your cameras and I want you to do your favorite stretch. And because I'm sitting, I'm going to do a calf and a hamstring stretch. And Lebo, if you could please tell me which of my students are shining brightest as they stretch. Okay. And it's not just to be silly we're doing this, it's actually really helping us learn productively. And so take a moment to just stretch out whatever part of your body needs stretching.
Come on, guys.
She shines behind the camera.
Behind the camera.
You have to shine right to get to Cape Town. Stretch it out, guys. Come on. And if you can, turn on the
I
camera.
think you take the cup on this one because no cameras are on.
Everyone's like 9. Oh, my nose is blocked. Yeah. So guys, I hope I'm imagining these fantastic stretches behind the camera. But give it the best that you can. Your body will thank you for it later. Okay, let's do a little brain break. So you know the drill with these, just to let our brains go a little bit off the wheels for a bit. Can you tell me what a lemon plus a watermelon plus a peach is? And if you say fruit salad, I'm going to buzz you out. So let's get some numbers. Okay. Let's see what you can do. Let's run away from trigonometry for a moment. So I see Corso has helped us a little bit with the green apples. They are going to be 3 each. And I think I agree, but the second one is a bit trickier. How do we get our our next one. Maybe the red apples could help us. Musa is helping us out. Sarah is helping us out there. I think you're onto it. The red apple is 1. And then the lemon is 5. So the orange or the peach looks more like a peach to me. And then I want to know, what is this, guys? What is the final, what's the final thing going to be? Dawn has given a hint on the watermelon. Let's see if I agree with Dawn. Dawn, I agree with you. That's 7. And Dile has helped us out with the orange. So that's 2. And so what is my final answer going to be, guys? What is it going to be? It's not going to be fruit salad. It's going to be, and I think the first one I can see there was it Dawn or Abnejo. And so it's going to be a 5 plus a 7 plus a 2. And we are 14. And we are happy about it. Okay, so hopefully you've had your stretch, because if you have had your stretch, you are ready to roll for the second half of the lesson. And if you haven't, it's not too late. Your body will thank you for it. Let's get back to what we were doing. So we've learned about this new tool, which we're going to use to find areas of triangles. Okay. Then let's see if we can make it a bit harder. Find me the area of this triangle. I want to see, and over to you guys. Okay. Cool. Wow, everyone's flying. Would somebody like to give us a hint? I love when students give each other's students hints. What would, if you're feeling a bit stuck or you feel like you understand this, how would you, what hint do you think would be helpful to other students? So I see Nontokozo has said AC will also be 7. And I think I agree with her, because it's literally saying on the question, these two little parallel lines mean they're the same. Now, what about, what's the next important step that I need to recognize? Who would be happy to share? Anyone want to raise their hand and share your knowledge? I see in the chat. Oh, there we go. Younger. Younger, what do you think would be helpful?
So I think,
yes.
So I think that because AB and AC are equal to each other, the angle of AC will also be 50 degrees. So then, since it is 180, sum of triangles is 180, just say 180 minus 100, then it will give you 80. Yeah, it will give you 80.
Younger, you have been so helpful. Thank you so much. So one of the things I want to point out with is, in order to do this question, you have to do some pre-work. The first one is to realize that AC is 7. And then you realize that, and we did this in the previous lesson, if the angles are opposite equal sides, the angles must be equal. And then we can work out what angle A is, and that's 80. And now we can use the area rule, which is a half 7 times 7 times the sine of 80. Now, the problem is we also need to write down reasons, guys. So what will our reasons going to be? I'm just going to actually bring the answers up for you so that you can see them. So you're absolutely right that let me get, the answer is going to be 24.13. But what I want to point out is before you could do that, you actually had to write down some reasons. So when you wrote down, you had to write AC is 7 and say, okay, that was given. And then you worked out, okay, well, I would just say C is equal to 50, and that's angles opposite equal sides is the acceptable reasons. And then you could work out A, which is 80, and that is sum of angles in a triangle. So don't forget that you're perfectly right doing the maths, and you can see the rule, but if you deduce a fact, you do have to give a reason. And so I just want to point that out. But I'm pretty sure 24.13 units squared because of the fact that it's an area. Okay, now that was quite a bit harder. Give me a thumbs up if you're still feeling good. Give me a thumbs down if you're feeling a bit lost. I want to get a feel for the class, and since there are no cameras, the thumbs is how I'm going to do it. Okay. And again, don't be afraid to vote the other way, guys. Honesty is the best policy. Okay, well then let's look. Actually, you know what? In this question, okay, let's see where we get stuck in this question, and we'll go from there. Try and find me the area of this triangle, or if you can't find the area, tell me why you can't find it. Okay, so that's the question. And I'm asking you to find the area, not of a triangle, but of a quadrilateral ABCD. Now, what is quadrilateral ABCD? It's going to be this one. Now, I want to leave it open and say, try and find it. And if you can find some of it, tell me what the sum of it is. If you get stuck, tell me where you get stuck. I want to see what you can produce as you try and answer this question. Over to you guys. Sihao has asked, do we find ABD first? Sihao, I think you've given us all a good hint. I think to find a quadrilateral, we don't have a rule for quadrilaterals at this stage. Well, we actually do from grade 9, but we need the height. I think a good way to do this is to start finding the triangle part that you know. And I think ABD looks like it would be a good way to go. Okay. Okay. Dawn, you're onto something. I like that. Dawn, would you mind coming on the line just to explain to us what you mean about BD? Because I think you might be onto something here. Could you maybe explain what you mean by BD, if you're able to? I'm not sure if you're able to. But if you just put your hand up, you can ask us live. Otherwise, if Dawn's not able to, is anybody else able to explain to us why is BD coming up? So while we wait to see if anybody can help us with BD, I do think that triangle ADB should just be a half times 7 times 11 times the sine of 110. Now, what is that going to give us? A half times, yes.
Katleho has her hand raised.
Okay, won't you unmute her? Or him? So I get 36.18 for just triangle ADB. Now, Kakleho, could you tell me a little bit about the next part? What?
Okay,
Why were you
hi,
thinking
sir.
about BD? Hey, how's it going?
I'm getting you, sir.
Very good, very good.
So, the reason why we need to get BD is
Yes,
because BD and DC are adjacent, and that's how we would find the area because that's where the angle is.
exactly, exactly. So, can you do this question without BD? You can't, huh? Would you agree with me? I don't know if you can hear me, Kaklejo. I think, oh, you muted yourself again. Don't worry. So basically, what Kaklejo was saying is it's fine. You can get this first triangle here, right? So you can get this part using the area rule, all good. If you want to use the area rule again, the problem is to find the triangle in pink. I feel like I've gone back to primary school here. I'm enjoying coloring in. Is you need, okay, you need to figure out BD. And at the moment, you guys do not have a tool in your toolkit. Now, the good news is next week or the week after, I'm going to tell you about the cos rule. And the cos rule, when you've got two sides and an included angle, you can figure out another side. It's just that I'm not going to go there today. But what I wanted to do in this question is I wanted you to see that basically why we need BD to solve the second triangle. So if you understand why the BD is important, give a thumbs up in the chat. I just want to make sure you understand the logic of why we would need another tool in our toolkit. So thumbs up if you understand it, that why we need BD. And I promise future attractions, we're going to get there. Okay, fantastic. And then we'll be able to find the area of quadrilaterals because all triangles, all quadrilaterals can be written as divided up into triangles. And so that's going to be quite a powerful thing. Okay, last type of question of, okay, not quite the last one. Let me come back to this one if there's time. Let me go through this one. We've done these already. Okay, here's a little bit of a sneaky one. And we're going to finish today's lesson with this type of question. This is a slightly different question. It says, I'm going to give you the area of triangle XYZ. So there's triangle XYZ. I'm giving you the area. Awesome. However, I want to know the angle that is sitting inside this. And I want to see, can you figure out which of the four options is correct? And if anybody would, after you've voted, maybe tell us what you did to get there, that would be awesome too. Notice it's a different type of question. See what you can do, guys. Just think like, how would I work this out? I'm interested to hear actually, because there's different ways of doing it. So some people are saying B, some people are saying D. So I like it. There's some variety in I haven't worked out the answer, so I don't know yet. Some people are saying A. Okay. How is this question different? How is this question different? Well, normally we would say find the area, but we kind of know what the area is here. So I guess we could still write out what we did before. We would go 1/2 times 11 times 14 times something else. But in the area, we already know what the area is. We know it's going to be 48. So that's a little bit different. Would anybody like to come online and just give us maybe a hint or give us their idea of how they did it before I work it out? Because I don't know what the answer is yet. Dineo, if we could unmute you. What are you thinking about when you do this question?
So basically how my teacher told us is that when we're looking for the angle, we use SOHCAHTOA. So I use SOHCAHTOA.
Okay, but the problem is SOHCAHTOA is only going to work when you have a right angle. Do you see a right angle in this question?
Not really. I kind of pictured it for myself.
Yeah, but that's a fantastic. So Danero, like I think a lot of students were thinking that. And the problem is there is an option here which goes with SOHCAHTOA. The problem is SOHCAHTOA only deals with right angle triangles. And we're now in grade 11, we start to do trigonometry using all triangles. And so that is, thank you so much for bringing that up for us, because it's taught us a lot, but we actually will get stuck if we go down that route. Does anybody else have an idea? Yeah, and because of that's what I love when students feel comfortable participating. It's so important that we share honestly what we're thinking about, and then we all learn together. So what other ways could we do it? What other ways were you thinking about? Well, let's try and finish this sentence over here. We haven't finished it. Would you agree with me that the angle between 11 and 14 is x? So we would, if we were writing out this would be the sine of x. Now, isn't this x over here, isn't this what we're really after? Could we maybe move all these numbers around? So maybe what we could do is, what is a half times 11 times 14? I think that will just be 77 sine x. And then if I could just move the 77 across, I divide both sides by 77, I'll get 48 over 77 is sine of x. Now, didn't we learn about this in lesson 1? If you get the sine of an angle equals a number, how do we find x? Well, we go shift sine 48 over 77. So what I'm doing is I'm actually rearranging the area rule to make the x the subject of the formula. Now, see if you can get the answer now. Can you get the right answer now, guys? And let's hopefully I've multiplied correctly. I have. What do you think the answer is going to be now? So I guess I'm going to have to use my calculator because I don't know the answer yet either. So what I see is I see 38.56. Is there an option close to that? Well, it's not that. It's not that. And if I round to one decimal place, it will be 38.6. So what we have here is an example of moving backwards, guys. And all I did was I wrote out the area rule exactly as we did earlier in the lesson, except now I have filled in the area. And the thing that I am looking for is this x. And what I had to do to get there was I had to work out what all that stuff was together. And that gave me the 77. And then I moved the 77 across and I used trigonometry. Now that was a bit tougher. So give me a thumbs up if you're feeling good now. Give me a thumbs down if you feel very lost. And if you're feeling okay, I'm going to give you another question like this to see how it goes. Okay, cool. So it feels like the idea is there. Take a screenshot if you need to. And let's do another one. Okay. So take your screenshot if you need to, and then we'll do another one. Okay. This is a similar type of question. It's not exactly the same. There's a slight difference, but I'll see if you can do it. Use the same sort of method. So in this question, I'm giving you the area of the triangle is given. I am giving you an angle and I'm giving you a side, and I'm saying, please find for me the missing side. Give this one a go and see if you how you feel about it. I think this will be either the last or the second last question of the day. my tip I'll give you is I would start by writing out the area rule, just like you did earlier on, and just ask yourself, what is the thing that's missing? What is the thing that's missing? And how do I use my knowledge of equations to help me? So what would it look like to start with? Well, we know all area rule calculations have a half to start with. If only we had a way of naming this side. Well, we could call it little z, or we could call it xy. That would be fine. So I think a half times little z times 8 times the sine of 56 would be how I would normally do it, except the z is, we need to figure out what that z is. So that's quite important. What would be on this side? Well, they told me it would be 18. We choose a different color. Now, how do I get this z all by itself? It feels like that would be the answer, because z is the length of the side. So I seem to be thinking a lot today. So what are the answers coming in? A lot of people are going, some people B, some people C. Okay, let's see what happens. So this would just be 4 sine 56 times Z. And then I'm just going to move this whole thing across. And it's times on this side, which means when it comes across, it's going to be 18 divided by 4 sine 56. And what do we get? 18 divided by 4 times sine 56. And we should be getting about 5.43 centimeters, or 5.4. So the option will be C over there. All right. Now, the most important thing today is for you guys to understand this new tool called the area rule. And for about 40 minutes of this lesson, 45 minutes of this lesson, we just practiced that idea. These last 10 minutes, because you're in the standard class, we've added these extra questions to show you some of the varieties of questions that we can add. You know, as you go up the levels, the complexity of questions will increase. And so the point of this class is, if you find this part very overwhelming, it may be that spending more time in the foundations class is better. If you enjoy the challenge of these types of questions, then it may be that you're better suited to this class.